a boulevard of new era. This is an inter-college technical event where students from all the years in college take part and learn new skills. Let us begin with a short video of our September journey. Isha ma'am, if you could show the video. Thank you so much, ma'am. So, why big data? Big data refers to as challenging compatibility and competency associated with storing and analyzing such huge data set to provide a level for decision making that is more accurate and timely than anything previously attempted. Big data is the biggest game changing opportunity and paradigm shift for marketing. Many big companies like Amazon, American Express, Netflix, and others are using big data, and so it is really exciting to know about this growing technology. Today we have Shashank Mishra sir with us who will explain this topic to us. He is currently working as a software engineer at Amazon. He is also a YouTuber. He has worked as a data engineer at McKinsey and as a software engineer at Paytm. He has been a technical content writer at Geeks for Geeks. He has a good experience in big data and analytics. Sir is a pass out from MNIT and has a AIR 43 in NIMCET, AIR 10 in BHU, and AIR 19 in UPMCA. Good evening and welcome, sir. Over to you, sir.
Uh, thanks, Prakhar. And first of all, I would like to thanks the entire Innogeek team for inviting me and giving me this opportunity to share my experience about the big data with you guys. And first thing, I would like to call out that this domain is very, very, very vast, and it is also 100% true that it is very growing, and the future opportunities are so good in this domain. And the beauty of this domain is if you have good technical skills, programming skills, you have separate job profiles. If you are not someone who is that much into coding or something like that, then still you can avail good opportunities in this big data domain, right? So in the in coming minutes, I will try my level best just to give you the highlights or the high level overview of big data, what are basic terminologies and things are involved in big data, since obviously it is a vast domain. So many things or demonstration cannot be covered in like 1 and 1.5 hour session. If you guys it looks interesting to you, then definitely we can plan some demonstration class in future. I would love to do that. So my agenda of this webinar is just to give you the high level overview of this big data and basic terminologies. And in the last slide, actually I have prepared one presentation for you. So in the last slide, I will talk about an interesting difference nowadays, because so many freshers are confused with some similar job profiles of big data. If I talk about data engineering, data science, machine learning, so sometimes people get confused with them. All are same or not? What needs to be done in data engineering? What needs to be done in data science? So that kind of thing I would I'll try to deliver here. So in next few minutes, I will present the presentation, maybe in some rapid speed, because we have some limited time. And why? Because I just want to spare at least 15-20 minutes with you guys for your Q&A, because for me, to make the session interactive, questions are the best way, and I would love to take questions from you guys and would answer them. So like be ready with your questions, whatever you have, and whatever I know, I'll try my level best to answer those questions. So let me present that. So can you guys see my screen?
Yes, sir.
All right.
Yes.
So let's, yeah, as a short introduction, as a team talked about that. I'm working as a data engineer in Amazon. I joined Amazon recently. Just like I cracked Amazon in third attempt. So like it was a long journey for me. I was trying for Amazon since my college time. I got failed first time, then even rejected by Amazon second time, and now in this year 2020, in the March month, I was able to make into Amazon. Previously, I worked with like world's number one consulting firm, that is McKinsey and Company, and India's unicorn startup Paytm. I did my masters from an ITL Hyderabad and running a YouTube channel, e-learning bridge. I'll put the description in the chat box. You guys can have a look at it. Okay, so first is like what is big data, right? So big data always refers to a large amount of data which is pouring in from various data sources and has different formats. Or if I talk about other technical definitions, so big data is something which cannot be handled by the traditional databases. So traditional databases means we all know about the transactional databases like MySQL, Oracle databases. So these are the transactional databases. They have some limitations. They do not have that much compute capacity and all, and even the storage, right? So big data problems always are considered to be as problems which cannot be handled by the traditional databases. So in total, there are 5 V's. We call it 5 V's of big data, but 3 V's are very, very important and major. First is like volume. So obviously a big data problem will be a big data problem if it has a huge amount of data. Like if you have a 1 GB or 2 GB of file to process, then you cannot call it as a big data problem. In big data solution, we always process data in hundreds of GBs, TBs, petabytes, something like that. And second one is basically velocity. So velocity here also matters, like the pace or how rapidly you are getting the data in your systems and you are processing it. So that we call here the velocity. If I talk about, so there could be two things, like batch or historical data and like real-time data. So batch or historical data, what we are supposed to do is basically we process the data which is of like 2 days back, 3 days back, weekly data, monthly data, right? So even it like its volume is quite high. So that could also be treated as a frequency. Here we will treat the frequency as like weekly, monthly, yearly, and we have real-time data as well. For that, you can take an example of Instagram feeds, Facebook feeds, Twitter feeds, or Netflix stream, whatever movies are streaming, so or match streaming. So those are basically real-time data. You like the Twitter hashtag trends, like every seconds, like a hashtag gets changed, trending hashtags gets changed. So that means Twitter is something processing in the real time. Whatever feeds they are collecting from their entire system, they are processing it and populating the trending hashtags. So that is one, we call it velocity. And next is basically, you can say variety. So these three are very important V's: volume, velocity, and variety. So in big data systems, like there could be multiple types of data. Okay, so I will talk about in next slides what kind of data it could be. So as a definition means there will be multiple formats of data you will be getting in this big data problem or big data world. And now two other V's are like veracity and value. So value, obviously, big data has like no importance if you are not extracting something meaningful from it, right? So why like companies are dying or running behind this big data world, or every company wants to jump into big data solutions? Because they know the value of data and they want to extract something meaningful from it, so that they could improve even how their business are running. They can make some decision. So that we call like data driven decisions. So companies are running, that's why they are running behind the data and they know the importance of it. And veracity is like inconsistencies and uncertainty in data. So obviously if like the you are dealing with big data problems and data formats are different, then definitely there will be like huge amount of anomalies, inconsistency and uncertainty in the data. That we call it veracity. So I was talking about types of different like variety. So that is basically in big data, there are three different formats of data, like structured, semi-structured and unstructured. Structured is like organized data format with fixed schema, like to represent your data, you have some columns, names, data types. It is like well structured and well designed, having proper schema name. So example like relational databases, MySQL, Oracle, kind of that. And next is semi-structured data, like partially organized data, which does not have like fixed format. For like very good example is XML or JSON. There we all know like schema may change, right? So that's why we call it semi-structured data. Now we come on to unstructured data. So that is like unorganized data with an unknown schema, like audio file, video file, log file, some or pure text files. They like it is completely unstructured, have no schema. So there you can see structure like tabular format data, and unstructured like Instagram feeds, Twitter feeds, or likes, whatever we have, and semi-structured like forecast data, or like XML data or JSON data, whatever get exchanged between two applications or server. And now this is very important topic and interesting too, like why data is the new oil. Like we are talking about, we know its importance, but there would have been some benchmarking between the data and oil. So the data is essential resource that powers the information economy in much the way that oil has fueled the industrial economy. So that's like 100% correct. Information economy means the more you work on these data, or the more you work like fetching the meaningful insights from the data, in that way you will be able to increase the power of like information economy. And similarly, like obviously we know the oil, how much it is important to run the industries and how much it adds into the industrial economy. And second is like information can be extracted from data just as energy can be extracted from oil. Obviously, like from the data, the valuable part is obviously meaningful information, and from the oil, the meaningful part is energy, right? The data flows like oil, but we must drill down into data to extract value from it. Data promises a plethora of new uses like diagnosis of diseases, direction of traffic patterns, etc. Just as oil has produced useful plastics, petrochemicals, lubricants, gasoline, and home heating. So here, this point is basically emphasizing that if you have data, you are working on it and you are innovating, you are trying to basically segregate in different domains or in different sectors, then definitely something meaningful can be created in other domains as well. Like we try to create or we try to generate from the oil, like we process it on different layers, whatever basically uh, whatever output of different stage or different purification layer. From that point we can create something else like plastic, petrochemicals, lubricants, gasoline, etc. So that's how like data even working. The life cycle of oil is defined by process like extraction, refining, distribution. The life cycle of data is defined by relationship with other data, with context, and with itself via feedback and loops. So traditional oil powered the transformation era. In the same way, data as the new oil is also powering the emerging transportation options like driverless cars, hyperloops, which are based on advanced synthesis of data in form of algorithms and cognitive knowledge without use of fossil fuel. So the way like oil basically empowering the transportation era, or you can say traditional transportation era, in the new generation. So that kind of work data is doing. It is like we like driverless cars, like we are doing AI, ML, we are training the data, okay, and based on those decisions, like we are trying to create like data driven decision making systems, where systems basically we pass training and test data, we train our systems so that whatever correct and precise decision they could take, and that's the kind of thing we are doing with the data. The same we are doing with the oil. So the very very basic, or you can say the like fundamental of big data problems, or the foundation of big data problem is we should know about these two important things: distributed computation and distributed storage. All right. So if I take an example, so let's say you written a Python program, okay, to read a file, and let's say it is like 100 MB or 20 MB file, and like in even your Python program can handle it, okay, using your in memory, it can process it, okay. That is for like very very smaller files, but if data grows and like we are not able to compute it on a single machine or something like that, then you can say companies came up with new idea, like in in general what we were doing, we were passing the data to our code. Like we passed our input file to the Python code, it processed it and it generated the output. But what the new methodology was, why not like send the code to different data nodes, and then each and every node itself, like it will itself do its computation part and will generate like its own output, and at the end we can aggregate it. So that was the phenomena behind this distributed computation. So like in this distributed computation, what we will be having different commodity hardwares, which are connected with each other, and we call it as a cluster of nodes, or you can say every commodity hardware we call it as a node. And commodity hardware is nothing, it is basically a simple machine. It could be your laptop as well, which is having some sort of storage and like CPU and some network bandwidth. So like that kind of machines we call the commodity hardware. And when we process our data in such a way, I mean over a cluster, then we call it basically a distributed computation. Okay. And now second important part is distributed storage. So obviously I was talking about this part, like every machine like has some capability, and like its storage may extend at some fixed point, right? Even after beyond that you cannot store anything else. So, but in big data, we all know data will be in gigabytes, petabytes, terabytes, which cannot be handled by a single machine. So obviously, you need a cluster of, again, you need a cluster of machines, and like you will break your data into smaller chunks and will distribute across the cluster, right? So that is basically a distributed storage. And like this entire thing works like it will look like everything is getting processed on a single machine. Like there is a single program and you will treat it like there is a single file. Like under the hood what is happening you shouldn't care about it, but yeah, terminologies you should know. like how data is stored on different nodes, because obviously your like single file won't get stored on a particular or dedicated node. Your system will divide into smaller chunks and will store on different nodes. So that is basically a distributed storage. And obviously there comes a point like what if any particular node gets failed, then definitely we will lose our data. So whatever systems, whatever distributed computation and storage system nowadays we have created, those are like highly available and fault tolerant. Means if something goes wrong with any particular node, or if there is any failure, then obviously under the hood we are replicating our data on different nodes. So sometimes if there is anything wrong with like a router or a switch, particular switch where an entire rack of different nodes are connected with each other, there you can see these systems are like present on, you can say, we can call it a rack. Okay, so let's say something happens with this rack, then definitely your data is safe because it is replicated on different racks as well. So that's why our systems are like highly available and fault tolerant. So another very important term is like vertical scaling and horizontal scaling. So vertical scaling, like this picture, I would say is saying a lot, that I was talking about every machine has its capability. Beyond that, you cannot store on that particular machine. So for an example, let's say nowadays you are working on 100 MB of data or 1 GB of data, right? Then you have this size of machine with such different configurations, and let's say like your data, or you can say traffic, is getting increased on at some extent for your system. Then what you did, you added some extra RAM on your system, and you increase the capacity of your system. And again, like if traffic is increasing rapidly, you again did some configuration changes. So there vertical scaling means you are increasing the configuration and size of a dedicated machine. That is vertical scaling. But what happens in the big data, or even nowadays on different whatever like application, even in web applications, we used to call this term like your system should be scalable. Scalable means it should be horizontally scalable. So that means, let's say nowadays you are only handling 100, or you can say 10,000 user requests. Obviously, let's say your like business is running very well, and you are getting good user base. Obviously, traffic will be increased. And now let's say you need to handle lakhs of data, 10 lakhs of user requests, then definitely your system should be in a good state that you can quickly horizontally scale it. Okay, so in the like horizontal scaling, you can see uh, I am handling this data. I have one machine, traffic got slightly increased. I added another commodity machine and made a part of the existing cluster. So what will happen? Load will be distributed on another machine as well. So, and again, like the traffic is getting increased again and again, then definitely what I need to do, I simply need to add different machine in the existing cluster. That's it, we are done. And obviously it will make our life very easy, because otherwise if we are doing things on a vertical scaling, first thing is it every machine has some limitation, and obviously it cannot handle that much of user request or data, and that will cause a like breaking systems. So that's why horizontal scaling is very important. And now like in the next slides I will talk about two very like most important frameworks which even you can treat as a like basic foundation of this big data or distributed computation, distributed storage. So whatever now or like good frameworks we have with us, their basic foundation is Hadoop. Okay, so Hadoop is a framework that allows you to first store big data in distributed environment so that you can process it parallelly. Means it provides us the it provides us the capability to store the data in a distributed way and even the distributed computation. So there are three major components of Hadoop. First is HDFS, MapReduce, and Yarn. So HDFS is basically it allows you to store data of various formats across a cluster. So cluster, we all know it is a combination, or you can say batch of different commodity hardwares. So Hadoop basically works on a master slave architecture. So the master node, we call it name node, and the slaves, we call it as a data nodes. So data nodes means whatever data we have, we will be storing, that will be distributed or a partition, you can say, on different data nodes. And name node is there who handles everything, like it will create a, you can say, file image, like this chunk of particular file xyz, where it is stored. So let's say there is any user application which wants to do some computation on that particular block or that particular chunk of data. So like known a name node is something which maintains all the metadata related to like file storage and its particular location, so that when there is any computation required, like it could send the user written code on like respective data nodes where the that chunk or that block is stored. Next is like MapReduce. It is like software framework and programming model used for processing huge amount of data. MapReduce program work in two phases. Like first phase is map and second phase is reduce. Map tasks deal with the splitting and mapping of data, while reduce tasks shuffle and reduce the data. So MapReduce is nothing. It's just a methodology that was being used like to implement this distributed computation. So I will give you an example in next few slides, like how different phases works of this MapReduce part. And next one is Yarn. So obviously we know, guys, like let's say we are working on our laptop, we know about operating system. Let's say we open different applications, and obviously our see like operating system is multitasking. So like it exactly know what kind of memory and what kind of you can say resources this application requires to run successfully. So that kind of you can say that kind of management we also need in our clusters or in our like distributed computation. I mean, there should be someone who should take care all these things. Like if I written some code to compute something, then like how much memory this code requires, and how much internal memory it requires to compute the things, right? And where is the dedicated node where to create basically a process ID, or where we in big data we call it as an application ID. So these kind of things, like back and forth basically between the name nodes and the data nodes, or you can say basically it is a resource manager. Like if I talk about on a very high level, it is a resource manager. That means it is simply managing all the resource which is required by your code to do all the necessary computation. So that's the example, guys. In big data, the very common example is hello world. So like count frequency of each word in a text file is basically a hello world program of big data. So there you can see we have an input file. So you can treat it as let's say 10 GB of file. Okay, and input is split. So you can say, you can see this split, this is split, this is split, this is split. So in Hadoop, we call, like I was talking about this term, like you have input file, and Hadoop will basically store it in smaller chunks on different data nodes. So those chunks are being called as blocks. Okay, so like these are the blocks, smaller blocks, input splits. Uh, this one, this one, this one, this one. Now we will in this MapReduce code, we will write two functions. One will be map function. So map function, what it will do, it will simply read input and will generate key value kind of output. So here our main task is to compute the frequency of each word in the entire file. So this map task received this line as an input. It splitted it, like whatever logic we will be written. So the logic was split the each word by space and put one as a value in front of it. So here welcome is key and one is value, right? Because in this line the frequency for welcome is only one, so that is here. Similarly with these lines, right? And now map, the output of mapping phase is in the form of key value. So now the next task is reduce. So our main motto is to get this output. Like in, if every map phase, you can see there will be frequency one. Like Hadoop here, frequency for Hadoop is one, and this mapper task received this one as an input line. So that's why frequency of Hadoop is one here. But our end motto is to get this output, like Hadoop will be 3. So now the main point is to combine all these things. Whatever output we are getting from different map tasks, we need to combine it at one place and aggregate it. So there another step comes, like shuffling and sorting. So like shuffling and sorting means obviously welcome, like you can say Hadoop is present in this map task, in this map task, and this map task. So to aggregate all the things together, we need all the Hadoop keywords at one place. That's why we need to sort it and shuffle it, right? So here you can see, after doing this shuffling and sorting, each and like whatever distinct keys are available in different map tasks, they are located at a dedicated reducer task. All right, so there we have it. And now the reducer, what it will be doing, the final logic is to aggregate all the values for a different keys. Here Hadoop 3 good one, class 1 bad one is 2 times aggregated it, and here we have the final output. So that's how the like entire MapReduce kind of thing work in the Hadoop system, and that's how we compute the distributed data or the like larger amount of data in Hadoop system. So guys, like Hadoop was like something which was quite slow. Why? Because we talked about the cluster commodity hardwares. So everything will be treated as an external disk. So obviously we all know, when we read from external disk, so obviously there will be more and more seek time, because like there will be a greater seek time because first we need to you can say read data from external disk, and there again network bandwidth is required to pull the data or to send the data on different nodes, shuffling something like that, or to process it. So in order to avoid these kind of things, or you can say to gain much more speed in terms of computation, we came up with another good framework, that is like Apache Spark, which is very popular nowadays. And if you are targeting some good opportunities or roles in big data, then like companies would expect from you that you are aware with these good frameworks like Hadoop, Spark, and all these. So like what is Spark here? So Apache Spark is obviously again a powerful computation engine. Okay, like the same kind of thing like Hadoop was doing, Spark has also like the same motto, but it has like some enhanced features. Okay, so like Spark has four different components, like it is polyglot. So polyglot means methods or APIs are available in different languages like Java, Scala, Python, R. Speed, like Spark versus Hadoop. So Spark is basically 100 times faster than Hadoop. Why? Because Spark processes everything in memory. What I mean, basically, whatever computation it wants to perform, so the amount of data can be handled by the in memory. It will bring that data into the in memory and process it, and we all know if data is in memory, then computation will be much faster because seek time will be very less, right? So again, and the very important part is powerful caching. So I'll give you an example. So let's say to solve any distributed computation related problem, you written one iterative algorithm. I mean, there was, let's say you need to join two tables, uh, and whatever output generated by the join operation, you had to use it for like different aggregations, group bys, and all. Okay, but this is something which is repetitive. Again and again, you need to do it for different objectives. So there, what will happen? Let's say if you have written this kind of program in Hadoop, then those computation like join operations will be triggered again and again in order to perform different objectives within your single application, single program. But the beauty of Spark is, let's say you generated some output. If I from previous example, the like joined data set, what you can do, you can cache it, you can persist it. So what does it mean? Even if you write any iterative algorithm, so it will save the computation time. Means those join operations won't trigger again and again, and like it will be it can be read by different methods within the single application to perform different aggregations. So that is the like very important and beauty of Spark, like powerful caching. And next is like deployment. From deployment perspective, like or to work with Spark is quite easy, in comparison with the Hadoop. So like components of Spark is, guys, like first component is Apache Spark core APIs. So if you are someone who is writing any Spark application, Spark code, then different libraries are available in R, SQL, Python, Scala, Java. You can use it and fulfill your objectives. And so what was the problem in Hadoop? That either you need to code in Java, and since it was written in Java, Hadoop, or to Python, right? So means it needs a good kind of expertise, right? If somebody in organization who wants to perform these kind of computation, then you need to have a good expertise on Java or Python to do those tasks. But Spark came up with something interesting. I mean, like if you are someone who is not very much comfortable with writing Java codes, MapReduce, and very complex type of coding stuff, and but you are good with like writing sequels, then Spark ecosystem provided good libraries where you can write your entire logic in SQL, and under the hood Spark will compute it in a distributed environment. But means you do not need to worry about like if I'm not using APIs, I'm not writing things in a distributed way, then my code won't get executed parallelly. No, you just need to concern about your logic in SQL. That's it, and everything else Spark will take care of it for you. Next is Spark streaming. So I was talking about two terms, batch data and real-time data. So the problem with Hadoop was it was not capable. It didn't have any kind of methods or APIs which were able to perform the data in real time. It was only capable of doing batch processing. But Spark has this capability to process the data in real-time format. For that, we have a good terminology in Spark, that is D streams, dis D stream, discretized streams. Next is like ML lib. So if you want to perform any like machine learning kind of algorithms or perform such kind of stuff, then ML lib is there. Or if there is any data set where you want to establish a graph kind of relations and want to do a graph type of computation, then GraphX library is there. And if you are good with R, like R language, then definitely APIs are available in Spark R. We call it Spark R library. So they are again like batch data and versus real-time data that I talked, guys. So the collection of storage of data for processing at a scheduled time when a sufficient amount of data has been accumulated. So that's kind of a stuff we do in the batch processing. Like we wait for some time to elapse. I mean, let's say it's maybe one day, even a week, and when we reach at a threshold, like let's say we want to process the 100 GB data as a threshold. So when the accumulated amount of data is 100 GB, we send it to our system or code and it will get processed. So that is basically a batch. So for example, check clearing, generation of bills, credit card transactions, right? And in the real-time data, you can see from the diagram transaction event, like online computer, whatever processing was done, you updated the database, and again it is occurring in a cycle. So for the very good example, like reservation system and POS machines, like you swiped up your card, transaction happened, and we are done. That is like real-time processing. Or if I like this is the like pictorial notation, you can say, to describe about the real-time processing. So it has three components. First is you can treat it as a source, and these are like intermediate components where the real-time computation will happen, and this is your end part, like your data is being processed and you created some dashboards on top of it which are getting refreshed on the like real-time intervals. The best example is like cricket. In a cricket match, you used to see the over by over stats or graphs. So what is happening? Like there are dashboards which are getting updated in a real time. Means we are uh, transforming the data in real time, and then even like our dashboards, the whatever logic we have written, and we schedule it to get refreshed by every 5 minutes, 6 minutes, or like 10 minutes, 15 minutes, something like that. So in this real-time processing, you can see, guys, data can come from different sources. Like it could be server logs, network logs, storage logs, click streams, like whatever clicks are happening on your website, you are capturing it. So Apache Flume is there, which is another kind of framework which can help you to pull data from different sources and dump into different things. So here to process the real-time data, I hope some of you might have heard about the Kafka. So it is basically a pub/sub kind of model. So like to order to process the things in a real time, we all know like data will be coming continuously and we need to process it. So there are two things, like there will be someone who will be known as a producer, and there will be someone who will be known as a consumer. So producer and consumer. Producer will dump into data. Like Kafka is also again a framework. It has like a complete Kafka cluster where whatever data you are getting from real time, you will store it in a topic, and even that data set will be distributed in different partitions. And your consumer programs that could be written in like Spark streaming, those Spark streams will be treated as your consumer. They will consume data from the Kafka. Okay, they will process it, whatever logic you have written it, and then you can this downwards arrow, you can see here like different storage system. HBase is again no SQL database. Hive tables, HDFS again a distributed source. That means like this downwards arrow means whatever data or whatever transform data you are generating, you are dumping into the like distributed system, so that at a later point you can do a batch processing, and in the meantime you are populating the real-time dashboards as well. So this is the like overall real-time data processing here. Now guys, like what is NoSQL databases? I'm pretty sure like many of you might have heard about this NoSQL databases and what is the importance behind it. So definitely I talked about traditional databases. Things cannot be handled by them. So obviously we have distributed storages, but we have like distributed or you can say we have NoSQL databases. And why NoSQL means not only SQL. So like they are not something which provides you like ACID properties like atomicity, consistency, idempotency, and durability. Like so in RDBMS, they provide like ACID properties like transaction. If there is something, it will be like fully finished. Otherwise, it will be reverted back. So nothing like that with the NoSQL. They are designed with different methods and different techniques to serve different business use cases. And basically, you can say to handle big data or to store big data or transform data, so that it could be like read by different systems to perform the different kind of operations. So like here you can see like in NoSQL is an approach to database that represents shift away from traditional relational database management systems. To define NoSQL, it is helpful to start by describing SQL, which is a query language used by RDBMS. So in RDBMS, rely on tables, columns, rows, or schemas to organize and retrieve data. But in NoSQL databases, they do not rely on these structured and use more flexible data modes. NoSQL can mean not SQL or not only SQL. As RDBMS have increasingly failed to meet the performance, scalability, and flexibility needs that next generation data intensive applications require, NoSQL databases have adopted by mainstream enterprises. So that's what I was wanted to talk about, like why NoSQL databases are important. So obviously traditional databases cannot, or they do not have that much flexibility, or they cannot do any they cannot hold any kind of data sets which are basically compute intensive. All right, so let's say you have a huge amount of data and you want to perform any analytical query on, like let's say if I talk about 1 year of data, you put a filter on 1 year of data and you are doing extensive computation, then obviously there you should know about these kind of different NoSQL databases where you can perform these compute extensive queries. If you will perform that kind of compute extensive queries on RDBMS and databases, they cannot even handle it. So that's why these NoSQL databases came in picture. They hold your data in a distributed way, and even whenever you compute something, you perform any extensive queries, they will compute it on a distributed way. So example, like four types of NoSQL databases, like key value, document based, column based, graph based. So key value, we have Memcached, Redis. For document based, we all know the very popular one, MongoDB. And columnar databases like HBase, Cassandra, Google Bigtable. And for the graph based databases, we have Neo4j, FlockDB, Infinite Graph, something like that. And big data and the cloud are match made in heaven. So that's completely true, guys. So why I included these slides, I just wanted to give you guys a reference that if you are someone who are looking forward for these domains, then obviously we all know there are two kind of things, like on premises versus cloud. So on premises means there you need to set up everything by your own external machines, hardwares and configurations. Everything you need to maintain by yourself. And what is the disadvantage means high hardware cost, obviously, like medium backup cost, and then high maintenance cost. So if you are going or you are developing any application which is like running on premises thing, then that means like we are making our life hell, because there will a lot of things need to manage from our side. And that's why we all know like how companies and different companies are rapidly shifting on cloud. Why? Because of its advantages like low hardware cost, backup and recovery cost, security, compliance. So if we talk about this cloud thing, that's why it becomes very very important. And nowadays, whatever cloud providers we have, or even whatever in the industry, wherever we are working on different big data solutions. We used to write these things or create these kind of application on the cloud using the cloud services itself. So that's why I'm emphasizing on this part, guys. Please explore these things. There are cloud providers which provide these services on free account with some limitations. You can explore these. So if you somebody starts working on big data, then I would recommend for a local setup, you can do it on your machines, local machines. But if you want some real-time exposure of distributed computation or storage on cluster kind of thing, then definitely go for small services on different cloud providers. So the popular three like GCP, Google Cloud Platform, AWS, Microsoft Azure. So in the big data like environment, this guy like AWS is nowadays ruling a lot. Every day they are coming with very good services in the field of big data, and like doing some really crazy stuff. So this is the last slide, guy, of our presentation. So I just wanted to give you, like, obviously there are so many job profiles in this domain I talked about. So if you are someone who are too much into like programming, you want to work on backend systems or network protocols, or so much on different cloud services, something like that, then there are few profiles like data engineer, data scientist, machine learning engineer, big data developer, like that. But if you are someone who do not like programming or doing coding that much, but you are good with your like problem solving skills, I mean, if I give you any use case, you can come up with good approaches. So then like there are profiles like business analyst, BI engineer means business intelligence engineer, or data analyst. So these kind of profiles are also available. So they're like these guys are only supposed to work on ETL tools or data visualizations, data exploration, something like that. So the profiles which are something related to the like coding part and these stuff. So data engineer, data scientist, and machine learning engineer. So like in few points I would just like I would clarify the difference, because most of the time, like even I used to get ping from different folks on LinkedIn because they are confused. They keep asking me the questions like, do I need to learn or do I need to work on my coding skills or data structures, algorithm skills for too much for this data science profile? Because they are not clear like what actually the roles and responsibilities, and these are the profiles like you can get a you can gain a good expertise when you are working on industrial projects. Then definitely it will clear your thoughts about the actual roles and responsibilities. So for a data engineer, if I say these are the first layer means uh, like there is a company or there is a system which are working, which started or thinking about to work on big data problem, and they know they have some data at point X, right? And they want to bring it into their systems so that their business analyst or data scientist create something on top of it, or can basically extract some meaningful information from it. So it is the responsibility of a data engineer to create those kind of scalable pipelines or to perform complex transformation on the fly, so that they can generate the relevant output which is required by the data scientists, machine learning engineers, and different business teams. Because business analysts, data scientists, or other teams, they are not someone who know the coding part or who know the like coding part, or how to deal with the source and destination, how to make the data available, do the transformation, something like that. So that's here data engineers come. So as a data engineer, we used to write complex, optimized, and scalable data pipelines and perform the transformations on the fly by writing some business logics. So that is the actual role and responsibility of data engineer, and that's why knowledge of data structures and algorithms becomes very important for data engineers. And this is the stuff like every company will ask. If you are applying for data engineer role, they will definitely ask you about the data structures and algorithm questions, because you will be coding something, you will be dealing with backend systems, you will be looking at APIs, you will be like will be doing such kind of stuff. That's why it becomes very important. Next is like data scientists. So they are someone who are supposed to be good in mathematics knowledge, and I won't say this is something you should have a prior knowledge, because these things can be learned like while working or developing things. So but yep, your mathematical concept should be very good, and these guys are someone who will work on downstream systems which were populated by data engineers. They will be working on smaller data sets or very clean or concise data sets, just to create some mathematical models. For an example, like predictive modeling. So using those transform data, training and test data, they will try to come up with good fit mathematical models which can like serve the different use cases, like productive uh, predictive models, or fraud detections, or something like that. So obviously there should be something like there should be a good mathematical model which could find different patterns on work on different patterns, and based upon that it could take a decision. Next is like machine learning engineer. So they are like all-rounder kind of stuff. So data engineer did the main part for you, data scientist did the main part for you on a smaller data sets, but now the important part comes from the machine learning engineer. Means they will receive those good fit mathematical models from data scientists, and now it is the responsibility of a machine learning engineer to implement it on a large scale of data sets. So from the implementation perspective, machine learning engineer should know the roles and responsibilities of a data scientist, and some sort of and some subset, or you can say subset skills of a data engineer as well. That is the like combined roles and responsibility of a data engineer, data scientist, and machine learning. So always do not get confused about job profiles. Like with whatever you are targeting and whatever you want to become in the IT industry, spare a good amount of time, dedicate a good amount of time to understand its roles and responsibilities carefully, so that you can adopt those skill sets which are really really relevant that particular profile. So that was the like main motto to like clarify the difference. So yep guys, that's the end from the presentation side. uh, Now I'm like open for the questions.
Yes. Thank you,
You
sir, for
guys
that.
can continue with your questions.
Yeah. That was a very informative presentation. So let's start with the question round. I can see one question, some basic question. How can I start learning big data? What is the path track should I follow if I'm total beginner in this field?
So like that's what I talked about. Different key points I highlighted, like knowledge of distributed computation, storage, vertical scaling, horizontal scaling, basic framework, and found you can say foundation was Hadoop and Spark, right? So you should start from there first, and obviously when you will start working on these things, you should have a good understanding of programming as well, data structures and algorithm as well. You should understand some level of cloud services as well. So but whatever I mentioned in the my presentation, that was the basic foundation. I'll definitely share that presentation with the team. They will forward it to you. You can take a reference, but trust me, that was the foundation. Even I started my career as a software engineer, but when I moved into this data engineering domain, that was the path I opted, and I am here right now.
Okay, thank you, sir. The other question, it seems like, is there any easy way to migrate from Hadoop into a relational database?
uh like I didn't get this point, like
Uh,
can you repeat the question?
is there any easy way to migrate data from data Hadoop into a relational database?
See, that's what I'm saying. If like when companies start working, or even we should start work on any particular big data problem, then we should understand whether it is a big data problem or not. That's what like the very first point I discussed in my presentation, that big data problems are something which cannot be handled by the traditional databases, right? So that's what you should understand, whether this problem lies under the big data problem or not, right? If it is a like a file which is having 1,000 records or 10,000 record, then definitely you can handle it, or you can process it in or store it in your RDBMS. Then there is no point to store it any distributed file system, all right, like HDFS or Hadoop, or even to process it from like MapReduce program. But if it is something huge and it follows the different V's of big data, then it is a big data problem, and there Hadoop and HDFS will come into the picture. Then there is no role of RDBMS, and there is no sense of migrating it into HDFS to RDBMS.
Okay. And how can we create projects using big data?
Yes, definitely. That's what I was saying. If you are learning something, like after this presentation, if somebody start looking at these frameworks or projects, then definitely whatever you are learning in parallel, please create some smaller dummy projects, so that you will learn different challenges of it, and you will deep dive into it. And then again, definitely in the data domain, if you are creating some projects and then you are targeting some good companies, or like even in your campus placement drives or off campus, these are some booming technologies, and if you are creating something fascinating on top of it, then definitely it will help you to ace those opportunities.
And sir, lastly, a person is asking, ki, sir, what approach I have to follow if I want to go from profile and have approach to a company? How can I approach a company by creating some profile in big data? How can I create a profile basically for big data so that I
Okay.
can work for a company?
All right. So the first important part is like it shouldn't be like that. You know about few basic frameworks. You looked at it. You created some smaller projects, and then you started applying on it. Uh, I don't think so. It will help you. So, like, if you want to make a career in these profiles, or you want to start your career in these profiles, then definitely you should have a very, very good understanding. Like, first, dedicate a good time to choose a correct profile, whether you want to are interested in the programming side or the non-tech side, right? If you are interested in programming side, then what is fascinating you more, like data engineering, data science part, or machine learning part? Even if in
Yes.
non-tech part, then whether it is BI engineering, business analyst, data analyst, first dedicate a good time to explore like what looks interesting to you. When you are done with that part, you know like data engineering is the correct profile for me, suitable for me, then try to create a good roadmap, like what all basic foundation or what all basic skill sets you need to become a data engineer. First, try to gain a good expertise on those skill sets, create smaller projects or simpler projects so that you could deep dive into different skill sets. Once you are done with that part, then jump onto some big projects. Like there are very or like various kind of problem statements on social like problem statement you can find on different platforms like Analytics, Vidya, Kaggle, or on some like open source platforms. You can take those problem statement as a reference and try to visualize like how you will solve it, and then create good projects. And like dummy data sets are available on like Google, you can download it from there and then definitely work on it. This way you will be able to make a good profile. Otherwise, like I don't think so any company would entertain like only fresher level kind of skill sets, at least for these profiles.
Yeah, sure, sir. So for the last bit, if you could open your webcam, we could have a screenshot of the
Oh yeah,
session.
sure.
I would request everyone who is willing to please open your webcam.
Can you guys see me?
Yeah.
All right.
Anyone else who would like to please? So for summing up, it was a great session, sir. I got to learn a lot, and I hope everyone enjoyed this amazing session. I was really hope that you will imply all you have learned today. Once again, thanks a lot, sir, for giving your valuable time to us, and it was totally pleasure to have you today with us. Thank you,
Thank
sir.
you. Thank you
Thank you
so
so
much,
much.
guys. Yeah, it was a pleasure. I always love to deliver like whatever I have experienced, and this domain is very booming. So I always love to deliver such kind of sessions, and I hope it could help you to like create your roadmap if you guys are interested in big data part. And in future, if like we will get a time, we will collaborate again, and I will try my level best to give you some demonstration so that it will give you much more
Sure, sir. Sure.
visibility and clarity about it. So I'm just pasting my LinkedIn and Insta ID. If you have any doubt, if you have any confusion ever, please feel free to reach out to me. I will answer your questions.
Thank you so much, sir. Thank you.
Thank you,
Thank
guys.
you.
Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you. Bye bye.